Hello, my name is Daniel Wieland.
And I'm Amanda Birch. In this video, we will discuss how energy input and molecular composition impact emission duration, which is the measure of how long it takes before a substance is no longer emitting photons. A substance is deemed to be no longer emitting significant amounts of photons when no peak above the baseline is observed on the emission spectroscopy graph. Increasing the initial energy input results in a longer emission duration. This can be conceptualized with the echo after someone sings in a large chamber. If the person sings softly, the echo persists for a certain amount of time.
La.
But if the person sings much louder, the echo will persist for a longer period of time.
La.
Because more energy is input, it takes a longer time to emit all of that energy. If energy continues to be input into the system, the duration is extended. This is equivalent to someone singing for a longer time.
The other major factor affecting emission duration is the substance involved. Molecules that emit energy at higher frequencies are emitting more energy with each photon release. So for the same input of energy, they'll have a shorter duration than molecules that emit energy at lower frequencies, provided that both emit photons at the same rate. This can be seen when voices are compared. For the same input of energy or loudness, a higher pitched voice has a much higher frequency of sound and the echo persists for a much shorter period of time.
La.
The lower pitched voice has a lower frequency, but the echo persists for much longer. These properties are evident in the emission duration of fluorescence. If a green dye, a red dye, and a mixture of the two are activated at the same time, the green dye will cease fluorescence first. This is because the green dye emits higher energy photons as opposed to the ones emitted by the red dye, and the green dye has a greater intensity. The mix will also cease fluorescence before the red dye because the red dye absorbs photons from the green dye's emissions, causing the red dye to emit energy at a greater rate until the input energy for the green dye is depleted. Finally, the red dye will have the longest duration because it emits lower energy photons at a lower intensity.
In summary, the emission duration is really representative of two factors: the distribution of energy input into the system, represented by a magnitude of energy input over a certain time period, and the rate at which energy is output, represented by how much energy is contained within each emitted photon. If the energy input into the system increases, it takes more time for all of the energy to be emitted, and so the duration is longer. If the emitted photons have more energy per photon, it takes less time for all of the inputted energy to be emitted, and so the duration is shorter, given the same rate of photons being released. The substance can emit less high-energy photons because it cannot emit more energy than it has absorbed. And those are the factors that control emission duration. Thank you for watching.